All right, hopefully the last video. I guess it depends how long this goes. You will need your calculator here, and you are expected to solve these all algebraically, not with the graphing calculator. You can use the calculator to assist you, but I will be expecting work to be shown here. All right? Okay, so starting, our goal ultimately is to solve for x. So we'll just have to look at the approach of, is there more than one x or just one type of x? And then our goal is to isolate the x. So starting with 43, I notice there's one type of x. Now, this is all connected together. So we won't be breaking that up right now. So the only thing I'm going to do is add my 3, which gives me this. And just to remind you, when we do isolate x, we're working backwards in the order of operations. So I moved my subtraction through addition. There is no multiplication or division. This isn't log times 4 or log 4 times x. So instead, what I'll have to do is to get to the log, to undo the log to get to the x, I'm going to make an exponent out of it. And when I make an exponent out of it, I'm actually making the base of the exponent. So if the log has a base of 4, my exponent is going to have a base of 4. So I'm just going to kind of write that there. So now the left side should read as 4 to the log base 4 of x as its exponent. Because then once this base of 4 is this base of 4, and they're the same, I can cancel them out. And then I get x equals 4 to the 5th. And then you could type in 4 to the 5th on your calculator. It would be 1,024. Okay, next one. So for this one, there's going to be 2 ways to solve. Regardless of whichever way I'm going to solve, I first need to move my addition subtraction. So I'm going to add the 4 over. And then I have 2 routes I can take. One route I can take is what we did in chapter 6 and realize that I could make 8 and 4 have a common base of 2. So there's 8 on the left, 4 on the right. And then I could put the original exponent in parentheses. And then once I see that the bases are the same, oops, I messed up there. Hold on a sec. It's not a 2 there. Let me fix that. It's an 8. All right, hold on. All right, 2 to the second. And I meant to put an x in here. Now that the bases are the same, I can cross them off. And my exponent becomes the math problem. And I'm going to get 2/3. So hold on a sec, I want to move this over here so we have more work. Okay, if we solve it the more current way, then now that I've done my addition subtraction, there is no multiplication division. I could undo the exponent because I want to get to x and it's in an exponent. So to undo its being in the exponent position, I would make a log out of it. So what that means is I would make a log with the same base as the exponent. And it would look like this. So log base 8 of what was already there. And then if I do that to the left side, I have to do that to the right side. So log base 8, and then I'd put the original 4 in there. Because then what will happen, and this is an x, I don't know, I keep rewriting this wrong. This log, since it has a base of 8, and the exponent has a base of 8, they cancel out, and I get whatever this is. Remember, you press the math, up arrow, enter. And you can just type this into your calculator. And as you do that, your calculator is essentially going to be asking you 8 to the what power makes 4. And that, again, that's going to be 2/3. All right, 45. There is one type of x. And in this situation, I have a log on both sides. So it's kind of like the first option I showed you on 14 is since the logs on both sides have the same base, I can cancel them out. But before I do that, it's got to be just the log with its argument, which means I got to move that 1/3 here. So that becomes log base 5 of 8 to the 1/3. 8 to the 1/3, that's just like the cubed root of 8, becomes 2. Okay, and now it's just the 2 logs with their arguments, nothing else. And so now that the logs are identical, just like the 2's were identical right here, I can cross out those 5's, and then I get a problem like this, and then I just add 9 for 11. Now, it is mentioning extraneous solutions. This is, we will tackle that at the end. Hopefully I don't forget to do that, so I'm going to make sure I make a little note. Which problems would I have to check for extraneous solutions? All right, so this one, again, one type of x, so I want to get x alone. So the first thing to get x alone is I'm going to multiply by the reciprocal of -4, so that leaves me with this. And that'll give me the other side. When I multiply that by a -4, it gives me a +4. And so again, you got two routes you could take here. If you like, the last chapter, I could write these both as a base of 2. So I don't need to touch the right side, but the right side could become 2 squared, and that's the same as 4. And then since those bases are the same, I can now solve, divide by -2, and get -1. The other option is, once you get to this point, is to get to the x, which is in an exponent, is I could log it. And I'll just have to make the log be the same base as the exponent problem is. So log base 2, and then I'd put the original part back in. And then I would go to the other side, write another log 2, and put what was already there. And then what will happen is these will cancel out. You're left with -2x. You would then type this into your calculator, which would give you 2, and then you get back to the same answer of -1. So I'm really not sure which method I prefer there, 45 or 46, on those two problems, because I like the canceling out of the bases, but that only works on some problems. Using the exponent to undo the log, or the log to undo the exponent, works every time. So that might be better off. I don't know. All right. So 47 looks a lot like 45. The problem is I have 2 logs. So what I'd rather do is just make it 1 log. So before I do that, I'm just going to bring this log down. And off to the side, I'm going to remember that I have to get that down to 1 log. So if I look at it as x plus 6x, that turns into x times 6x. So I'll have log of 6x squared. And now that they both have their invisible base of 10 there, I can cross these off. And now this is just a regular simple problem. Divide by 6, and then square root. And remember, we square root, we get 3 and -3. All right, the next one is an exponent problem. And this is not one I could get a common base. So there is no addition, subtraction, no multiplication, division. I just have to get to the x straight away, which means I'm going to log it. So that means if we take the original problem here, I will make a log with a base of 6.92. And then I'll do that to the other side. Because now this base can take out this base. So I have x, and then whatever x is, I'd press the math button, up arrow, twice that is, and then put in my respective numbers. And when I do that, I get 2.774. All right, next one. Again, very similar to the one above. And 45. It's actually more like 45. So what I'd like to do is just cross off these logs, but the issue is I still have this 1/2. So I'm just going to move the 1/2 here. And I'm going to actually rewrite it as a square root, because I think you guys might do better with that. And now that it's just a log with its arguments, I can cross those off. And now to solve for x, to undo the square root, I would square both sides. And that's going to leave me with 16. All right, a lot of exponent and log problems. All right, on this one, I see one type of x. I'm just going to work to get x alone. So the first thing I'm going to do is subtract my 8, move my addition, subtraction. So that leaves me with 11. Then I'm going to get rid of the 1/2 by multiplying by its reciprocal. So I'm getting rid of the multiplication division. So that's going to leave me with 22. And now to get to the exponent, I will need to make a log out of it. So I'm going to log both sides. So I'm going to log the left side, which means I've got to log the right side, put the original stuff in there. Whoops, not writing that correctly. I think 22 here. All right, and so what I need to do is make the base the same. So I'll have to throw a little e in here. So this cancels out, so I'm just left with x. I'll smooch it over here. And then log e is just, if you remember, your ln. So you can just go straight to the ln button, type in the natural log of 22, and you get 3.091. All right, next one, going back to chapter 5. R's in the denominator. They are the same type of R for now. So what we want to do is find the common denominator, and I cannot factor anything. So if we kind of look at this as fraction 1 and fraction 2, I've got r minus 3. And in the second fraction, I have a 7 times an r. So if I bring everything down, this is what everything needs. So the first fraction needs the 7 and the r. And the second fraction needs the r minus 3. And then once the denominators are the same, you can ignore them, and you can just focus on the numerator. So I get 28r equals 2r minus 6, and now subtract the 2r over, which gives me 26r equaling negative 6, and then I'll divide by 26. So my r is going to be this, and I'm just going to leave it like this. You're welcome to simplify the fraction, turn it into a decimal, but it doesn't matter. All right, we are getting there. Let's go to the next problem. So this is the last chapter. Maggie invests $300 into an account that pays 5% annual interest. So how much money will be in the account after 10 years? I do not see the compound word in here, so I will be using this formula. And my original amount, the beginning amount, is 300. 5% as a decimal is 0.05, and it's going to earn interest, so I'll put a plus. And then I'm going to go ahead and just put the 10 in, and then I can just type this whole thing into my calculator exactly as I see it. And since it's money, this time I'm going to go for 2 decimal places. All right, this one, again, I would probably follow last chapter's method and find a common base. And a common base between 64 and 1/8 is 8. So 64 can be 8 squared. 1/8 can be 8 to the negative 1. And then I'll put my original exponents in parentheses. And now that those bases are the same, I'm going to cross them off and then go from there. All right, so first I'm going to distribute. And then I'm going to add my 8x over. Then I'm going to add my 2 over. Move in here. And then I'm going to divide by 14. And again, I'm just going to leave it as 7/14. Oh, it doesn't look very good. 7/14 because I don't feel like simplifying it. But you are welcome to. All right, 54. All right, I need to solve for x. Right now it's looking like one type of x, but I can't get to anything into the parentheses unless I get rid of the 1/2. So off to the side, I wanted to remind you that that's the same as the square root. So if I want to undo the square root, I'll just square both sides. And that's going to leave me with 4x plus 12 equals x squared. And now I have more than one type of x, so I'm going to have to set it equal to 0 and move the 4x and 12 over. You want to move those over because it's going to be easier to factor if your x squared is positive. So I need factors of negative 12 that make negative 4. Here they are. And so now I can do x minus 6, x plus 2, and then set them both equal to 0 to get 6 and negative 2 as my answers. All right, let's see. Yeah, let's go ahead and just finish this video up, one video. All right, next problem, one type of x. So I'm gonna work backwards. So first I'm gonna move my addition subtraction, so I'm subtracting the 1. And then I don't see any multiplication division, so to undo that check mark, I'll use an exponent version of it. So cube root gives me a third power, which is going to leave me with x plus 6 and 27. And then I can just subtract the 6 to get 21. All right, 56, very similar to, let's see, problem 54, except to get to that x, because it's one type of x right now, I'm going to have to undo that square root. So there's no addition, subtraction right now, or multiplication, division. To get rid of that check mark, I'll be using a squared. So square it, square it. And then again, now I have more than one type of x, so I want to leave the x squared as positive and subtract the other 2 over. And then we can make our x. 4. And then my parentheses become x minus 5, x plus 4. So for now, my answers are 5 and negative 4. Okay, 57, going back to chapter 5, we will need to find a common denominator. There is no factoring. So if you look at the first fraction, you got x minus 3. Second fraction, you got an x. Third fraction, you have an x. So altogether, you have an x minus 3 and an x. So everything's going to need something. So the first one's going to need an x. The second one's going to need x minus 3, and so is the last one. And now that we have that common denominator, we can let it go and have the numerator. So 20x plus 2 with x minus 3, and then 4 with x minus 3. So distribute. Start cleaning this up. It's pretty messy, so I'm going to have 22x minus 6 and 4x minus 12. And I'm going to run out of room, so I'm going to erase my table. And now I'm going to move the 4x over to join the 22x. And then I'm going to move the 6 over to join the negative 12. Oops. And then I'm going to divide by 18. And again, I'm going to leave it unsimplified. You are welcome to simplify it. Okay, 58, just like 57, but we can do some factoring on the last one. It can become x with x plus 3. So again, if you can't see that common denominator, you need to make your table. If you can see it, don't make the table. But I'm going to have an x plus 3 with an x, and then the third fraction has both of them. So there's my LCD, x plus 3 and x. So everything's going to need both things. So the first one's going to need an x. The second one's going to need an x plus 3, and the last one won't need anything. So now that I have that same denominator, I can ignore it, let it go. And here's my numerator, first fraction's numerator, second fraction's numerator, last fraction's numerator. So I'm going to distribute, and I'm already noticing now I'm going to have more than one type of x. So I'll need to make everything equal 0. So let's bring along the x squared, combine these to 8x, move the 3 over to join the 18, and now I can factor. So I don't need my table anymore. So factors of 15 that make 8 are going to be 3 and 5. All right, so I'm going to get x plus 3, x plus 5. So my two answers are going to be negative 3, negative 5. All right, 59. We're going to try to factor because I see more than one type of x. First, there is no GCF, so I need factors of negative 10 that make 4, which does not exist. So we will be moving to our quadratic formula, where a is 2, b is 4, and c is negative 5. So it goes x equals the opposite of b, so negative 4, plus or minus a square root. I'm going to take b and square it, minus 4 times my a. I'm going to put the c in parentheses, and then all of that's over 2 times a. So cleaning it up, I'm going to have negative 4 plus or minus over 4. This is going to give me 16. This is going to give me negative 40, and then when I have 16 subtract the negative 40, and it becomes a 56. And then if you check out 56 on your factor program, you're going to notice that nothing's perfect about 56. So this is our two answers. One is using the plus version, the other is using the minus version. All right, next one. Marcus purchased an e-bike for $2,000. He borrowed the money from his parents at an interest rate of 3% compounded monthly. Oh, that's that crazy formula. If he plans to pay them every month for 2 years, how much will his monthly payment be? So this is the big formula. So we're going to start out with 2,000, 1 plus my rate as a decimal. Monthly is 12, and for 2 years, and then there goes my n again. So I just have to type this in the calculator. And when I do that, I get $2,123.51. Now, that's not the question. The question is, how much will his monthly payments be? So they're going to take this and split it for every month for 2 years, which means 24 months, which means he's going to pay his parents $88.48 every month. All right, 61, more than one type of x. There is no GCF, but I see 4 things, so we're going to do that grouping method. So in this first set, I'm going to factor out an x squared and be left with an x plus 5, which if you remember, that's my other x plus 5, which means I have to take something out. You can't have nothing there. You got to have a 1. So then my factors are the x squared plus 1, the x plus 5, and I'm going to get an answer of negative 5. And then once I do this, I subtract the 1 over, and I'll take the square root of negative 1, which will leave me with a positive and negative, since it's a square root, and 1, and since it's a negative number, I'll throw an I in it. All right, 2 more. 62. You take out a loan of $12,000 with an annual interest rate at 3.2% compounded continuously. That's that E formula. It looks like Bert. How long will it take before you owe $8,500? So if we start, 12,000 E with my decimal version of the percent. T is what we're looking for, and we want to see how long it will take before you're owing that much on your car loan. Okay, so that means probably the easiest way to do this is just go to your calculator. You can do a y1 and a y2. And when you do that, you're going to get t equals 13.527. Now, there's another way to do that problem, but I'm going to need a little more room. So I'm going to move down here, and I'm going to rewrite it here. All right, and this is our latest chapter where we can start isolating the t. So the first thing I can do is divide by the 12,000. And as I do this, I am going to get decimals, and I'm just going to leave those full decimal values in my calculator, and I'm just going to write the rounded version here. So there was no addition subtraction to move, but we moved our multiplication through division, and now to get to t, it's part of an exponent. So to undo the exponent, I'm going to make a log out of it. Now, this time, I notice the base is e, so I'm going to use an ln from the beginning. And then I can put this in for their arguments. And then what will happen, this e takes out this, so I'm left with this. And then I would type in ln 1.542, but I still have that whole thing in my calculator, so it's really better to use that version of it. Whoops, and I lost my 2 along the way. So when I do that and I just shorten that up, I get 0.433. And then I would just divide by that 0.032. And if you've kept those full decimals in there, you should get the same amount we did when we used the graphing calculator. If you shorten the decimals at any point, you won't get that exactly, but you would get close to it. Okay, last 2, absolute value, 2 answers. Because remember, this is a V shape, That's meaning y flies by at 10, so we are getting 2 answers. So first, moving my addition subtraction, I'm going to move the 2 over, so I've got 12. Then I'm going to divide by 2, so I got 6. And now I'm going to get the 2 answers by doing x plus 3 with 6 and x plus 3 with negative 6. So in one situation I get 3, and in the other one I get negative 9. So that would be like your negative 9 and your 3. And the next one, we have an alligator. So we're going to want to make sure our alligator's happy. But we're going to have a regular U, it's not flipped, meeting this line. And we're looking to see where the U is bigger. So it's this with negative infinity and infinity. We're just going to figure out those numbers. So the first thing I'm going to do is divide by 3. Then I'm going to square root, which remember that gives you 3 and negative 3. So I'll do x minus 5 with 3. That'll give me 8. And then I'll do x minus 5 with negative 3, and that will give me 2. So 2 here, 8 here. So my 2 answers are from negative infinity to 2, no parentheses, and then from 8 to infinity, no brackets. And that's it. Good job. Last review, last question. I'll see you. This is due the day of your part 2 final. That's it.